Today, in this video, we will start building a service provider network. To simulate in the diagram, I used Cisco IOS XE and IOS XR for the MPLS core and customer edge routers. In the diagram, we have two major ISPs, which are ISP1 and ISP2, and three transit or client ISPs. Here, we will configure OSPF and ISIS as our IGPs, MPLS, IBGP for VPN services, and eBGP. Let us start with ISP1 by configuring OSPF version 2 and OSPF version 3 for IPv6. Before the configuration, let me show you the content of this lab. Once the configuration is complete, desired services like VRF Lite, L3 VPN and L2 VPN, inter-AES communications, inter-VRF communications, and other services are expected to work. To begin with ISP1, we will configure OSPF version 2 first, using the IPv4 addressing plan in the screen. To save time, I've already pre-configured the basic configurations, including the IP address of each link. Let me show you quickly the IP address configuration in each router and test all the point-to-point connectivity before moving on the OSPF configuration. All the point-to-point links connectivity are successful. We can now proceed with OSPF configuration. Let us start with OSPF version 2 for IPv4. For our task, configure OSPF version 2 on all routers in ISP1. Use process ID 1, and all the routers should reside in Area 0 only. All the internal links should participate in the OSPF process, including the loopback interface of each router. Do not send OSPF hellos to interfaces that do not have OSPF neighborship, including the loopback and any links facing the customer or another ISP. Once complete, all the routers should reach each other via the loopback IP address. To complete and achieve our task, we will configure OSPF version 2 step by step from basic to OSPF security and optimization. For the basic configuration, enable the OSPF process, then set the router ID, which is the loopback IP address of the router. For now, use the network command to advertise the interface links to the OSPF process. Then configure the loopback interface as passive. Let us start with XE Router 1 and configure basic OSPF. First, make sure to check if there is an existing IP protocol and OSPF process in the router. That is all for the basic configuration. Copy the commands, accept the router ID, and apply to the remaining routers. After the basic OSPF configuration, we can use several commands on the screen to verify its operation. Reachability is successful, and each router now has a full view of the network in ISP1. Next task, change the network type of all the internal links to point-to-point to improve convergence by avoiding DR or BDR election. Then, change the network type of the loopback interfaces to advertise the correct subnet mask in the routing table. Changing the network type is done under the Interface Configuration mode. Now change the network type of each interface on all routers under the OSPF process. After changing the network type, we can see that the state is changed to P2P from DR or BDR. The network type of each interface under the OSPF process is successfully modified. We can now proceed with the next task. Let us proceed with OSPF path manipulation. In this task, traffic from each PE router must traverse XE router 3. Before we continue, it is a good practice in modern technology to modify and increase the reference bandwidth. Here, in our lab, let us use 1000 megabits per second for the reference bandwidth. To achieve our task, increase the cost on both ends between XE router 1 and 2, XE router 1 and 4, XE router 2 and 5, then XE router 4 and 5. Once done, conduct traceroute in each router to verify the updated path. OSPF cost is change under the interface mode. Let us use 100 for the value of the cost. Reference bandwidth is changed under the OSPF process. The command is autocost, reference bandwidth, followed by the value. Let us use the value 1000 M. Now change the cost of the links under the interface mode using the command IP OSPF cost, followed by the value. Let us use 100 for the cost value. In changing the cost, make sure to change on both sides since the effective cost is always outbound. As we can see on the routing table, the traffic now traversed to X router 3 based on the next hop address. All the cost of those chosen links are now increased. Conduct traceroute in XE router 1 to verify. We are done with the OSPF path manipulation. We can now proceed with the next task. Next task, make sure that OSPF reconvergence begins in less than 1 second if the link to XER3 fails. Activate BFD on all the links of XE router 3 facing all the other routers. It should be done on both ends. BFD is activated in interface basis and using 2 lines of commands only. We will use BFD instead of fine-tuning the hello and dead interval since the minimum only is 1 second. In BFD, we can set it in less than 1 second. Let us begin in X router 1 and set the BFD. Here, we have set the amount of time to send and receive hello to 250 milliseconds with multiplier of 3. In total, after 750 milliseconds, if the link is down, the router declares the OSPF to be down. BFD is already set on all the desired interfaces. Let us check the BFD status. We are done with BFD. Let us proceed with the next task, which is OSPF security configuration. Next task, configure clear text OSPF authentication between XE router 1 and XE router 2 and XE router 4. Configure clear text OSPF authentication between XE Router 5 and XE Router 4 and XE Router 2. Use the password Network Lab. Configure MD5 OSPF authentication between XE Router 3 and all the other routers. Use the password Network Lab. For the commands, in our lab, we will activate it under the interface configuration. Let us start with clear text configuration in XE Router 1, XE Router 2, XE Router 4, and XE Router 5. As you can see, once the authentication is applied in one end, the OSPF neighborship went down on that link. Let us proceed with the other routers and finish the clear text OSPF authentication configuration. Now configure MD5 OSPF authentication in all the interfaces facing XE Router 3. In XE Router 3, configure MD5 OSPF authentication in all the interfaces. We are done with the OSPF authentication configuration. That is all for OSPF version 2. In the next video, I will show how to configure OSPF version 3 in ISP1.